Hello everyone. So I'm going to present my second project in the course, which is try to fit machine learning models into my crime data. I'm basically the only author of the project, so if I stuck somewhere, please forgive me. Okay, so let's talk about the motivation of doing this project. I believe since law was first established, crime has always been a very widespread issue in the society. There are numerous influential factors such as the income level, education are influencing the occurrence of the crime, and researchers are conducting countless research to investigate the issue. And I also feel like this could be a great opportunity for me to actually incorporate machine learning models into the crime data to see if there are some influential factors that are impacting the number of incidents. So the objective of the project is going to be predict the number of crime incidents using various machine learning models and compare model performance and identify potential improvement to the model. So the data I get is from National Crime Victimization Survey in 2020, I guess. And the original dataset has, the clean dataset actually has 8,043 observations and 81 features. This is the source, the website I download the data from. And I would use three models in this project. So the first one is linear regression with both L1 and L2 regularization, and the decision tree regressor. And the final one is the random forest regressor. Okay, let's go to the data exploration and model building part. So I did not include all the data cleaning process in the slides because it's kind of long. And generally what I did is to eliminate the null values, which include missing values or values coded as out of universe, and also handle the outliers, and which you can see in the notebook. And the feature selection. Here are my features selected from the dataset. So my target variable will be the number of incidents. So it's like a numeric value representing the number of incidents happened to an individual in a given year, which is 2020. And the feature I selected from the data includes urbanicity. So if you're living in a rural area or urban area, the gated, if the individual lives in a community with a gate or no gate. Marital status, so if you're married, if you're widowed, if you're divorced, etc. Your age, the sex, which is a binary classification, male or female. Race, there are 17 different options, different levels coded in the dataset, which you can see the detail in the codebook. And the education level of the individual, 17 different income levels. The region, it's like a geographic region, if you're living in the west side, east side, north side, and whether the incident involved a weapon. So here's a pretty brief EDA for all the features I selected from the dataset. This is all after cleaning and alignment, so everyone has 8,043 observations and a very brief summary statistics over there. And after that, what I did is to split the data into training, test, and validation. So what I did is like a 70%, 30% split. I split 70% data to the training set and 30% to validation and testing set. So both the validation and testing data set has 15% of the data. So after splitting, the training data set has 5,577 observations, and for test and validation, each have around 1,200 observations. And let's proceed to the model comparison part. The first model I tried is to use a linear regression. So this is the basic model I used. It's like that. I also tried to use region Lasso regularization to improve the performance of the model. I will show the detailed statistics later, but spoiler alert, they did not improve a lot. And the second model I tried is to use a decision tree regressor, which this is the best. After fine-tuning, this is the best model I have. So I set the criterion equals absolute error, and I set the maximum dips equals 30, which I have the best statistics over all other parameters I have tried. So I changed the criterion to squared error. I tried that. I tried the Poisson's criterion. I also tried different sets of maximum depths, which you can see the details in the notebook. But this is the best model I have from decision tree regressor. And the final model I tried is a random forest regressor. And this is also the best model I have. So I have, when I set the number of estimators equals 500 and set the criterion equals Poisson, I have the best model, the best performance. I also changed the criterion number of estimators for the fine-tuning, which none of them works as well as this one. Okay, so this is going to be the detailed statistics of the performance. So we can see that from the above three models, we can see linear regression is doing the worst job there. The decision tree regression model and the random forest model are doing a similar job, but I believe, from my opinion, random forest model is going to be the final pick for my project with the following reasons. So linear regression model performance, as I said, is kind of far from satisfying, which I believe is because the linear model only captures linear relationship, which is probably not the case for my project. And the decision tree model, even though improves a lot, but I'm afraid there will be an overfitting problem there. And with random forest model, it not only resolved the problem of overfitting, but also improved relevant statistics, which seems like the best fit for the model. And after select the model, let's see the result analysis. So to visualize one of the tree of my random forest model, here's the tree I have. I have 500 trees in total, so I only randomly select one of them to visualize it. And in the result analysis part, so I finally can touch upon the test data. I use the test data to do the prediction, and I feel like the prediction actually doing well because the performance for the test data is the same as the validation data. The mean square error goes down and the R-square improves a little bit. And from the result, I extracted 10 most influential features from the model. As you can see at the top is the age, with the following of income, weapon. There are some detailed coding here, which you can see in the notebook, so I won't elaborate a lot here. In the error analysis part, even though the model seems like doing a great job, but I believe none of the model is perfect, especially in this project. So you can see the final random forest model is doing the best job among all the three models, but they all have some pretty bad predictions here. This is the top 5, the worst top 5 predictions each model have made, and I will try to explain the reason in the following section. So in the strengths and weakness section, like the strengths of the linear regression is pretty prominent. It is very simple to build and it's very simple to interpret. But the problem is it will only captures a linear relationship, which in my case is just not going to work. The relationship between the features and target variable just may not be linear, which is why it has a pretty bad prediction here. And then for the decision tree regressor, the strength is like, unlike the linear regression, it captures a lot of complicated relationship between the target variable and the features. And unlike random forest, decision tree regressor is easier to visualize and understand since there will be only one tree of the relationship. But the problem is, I think it's going to be overfit for the data because decision tree regressor may just trying to fit all the features in the data, which may also include the noise in it. So it will not perform super well in another data set because it's going to be so specific to the data set and will not be generalizable, which is probably the reason why there are some huge errors we just see. And for the random forest, the strength is that it will solve some of the overfitting problem. And it just performed better in my project than the other models. But due to the nature of the random forest, it's just kind of hard to visualize all the trees. Since in this case, I have 500 trees, I cannot visualize them all together. And it is like a black box model, so you don't know what is going on in there. You can just see the result. So that's probably, I think, one of the weaknesses of the random forest. As for the error we just see, I probably feel like it's kind of related to the feature selection. Some of them may just not be highly correlated with the target variable, which is probably the reason why there are so many errors we see in the previous sections. And for the potential improvement, for the linear regression improvement, I'm thinking I can do some feature engineering, such as adding a interaction term in it to improve the model, and use log transformation can also handle the skew distribution. And I can change it to like a polynomial regression, like use a quadratic or cubic term, so it can capture the relationship rather just capture the linear relationship. And remove outlier, which I actually did in this project, but it didn't help a lot. But this is definitely one of the stuff you can do to improve your linear model. And for the decision tree regressor, besides random forest model, you can use pre-born or post-born the tree to avoid overfitting. So you can set like a restriction to maximum depths or like a minimum sample sleeve to prevent deep trees. And you can also do some feature selection, so identify and remove irrelevant feature to prevent the tree from memorizing the noise, which might be super helpful in my project. And random forest regressor, there's a typo there. I'm trying to find the balance because the computational expense for a random forest is pretty high. It's much higher than the single tree, so I may adjust the number of estimator to improve the speed of computing without reducing the performance of the model drastically, and increase the minimum sample split to prevent deep tree. And I can consider boosting method. There are some boosting methods such as gradient boosting, etc., to potentially for better accuracy. And yeah, this is basically what I have done for the project. And thank you all for listening.